Well friends, this is Guruji Online, and in my previous lecture you have seen what is electric field and how you can determine the electric field in case of isolated charges. Today we are going to find out electric field due to a dipole, due to line charge, due to a ring, and of course due to a disk. So let us go one by one. In our previous lecture we have seen, suppose you have a charge here, then electric field, suppose you want to find out at this point, this is a positive charge, this will have electric field like this, and what will be the value of electric field here? Suppose this is the distance r, then it is k q upon r square. This is what we had learned due to the single isolated charge we have learned. And if there are more charges, then we can add the electric field at the point where we have to find out. So, and what about k? K is nothing but 1 upon 4 pi epsilon 0, and this is called electrostatic constant also. Now let us see what is the dipole. Dipole is nothing but, it is a combination of two unlike charges. Suppose this is q and this is minus q, and the distance between them is d. Correct? This is the dipole comprising two unlike charges with a very small distance in between them. Now we want to find out the electric field at this axis, same axis, at point P. So let us see how we can find out the electric field due to this dipole at point P. Now let us analyze, due to these two charges, what will be the electric field here. Due to this Q, it is a positive charge, so it will have an electric field direction like this. This is E. Suppose this is E plus, and due to this it will have an attraction, so this will be E minus, suppose. So the net effect of these two electric fields will be the electric field at point P. Suppose this point P is, this is z distance from the midpoint of this dipole. This is dipole. And what is dipole moment? Dipole moment we denote by P, and this is nothing but Q into D. This is the dipole moment of this dipole, and its direction is always from negative to positive. Correct? So now what is basically electric field at P? It will be nothing but E plus minus E minus, and this is nothing but your Q, KQ upon, what is this distance? Z minus d by 2 whole square minus k q z minus d by 2. Sorry, this will be plus, because from this the distance of P will be z plus d by 2. Now we can simplify this. KQ suppose if we take z square common, correct, then what will be there? 1 minus d upon 2z whole square minus 1 upon 1 plus d by 2z whole square. Correct? You can again simplify this as k cube upon z square. This will be, now this into this if we do, then it will be d upon 2d upon z divided by 1 minus d upon 2z, this square and this square. Correct? Now let us make some approximation. Actually d is very less than z. Then this factor can be 0 and we can simply write 2qd upon z cube, or we can write k2p upon z cube. So this is the basically dipole electric field at P due to this dipole. Means it is at the axis of this at a distance of z. It can be this also, this can be here also, and this can be here also. The only thing is you have to take the appropriate signs while driving the formula. Now in our previous derivation we have seen the electric field at this axis along the line joining the two charges. Okay, now let us find out the electric field. It is the line joining the midpoint of the dipole, and it is at x distance from this midpoint. Correct? So what was the, in the previous case, what was the electric field? That was k 2p upon z cube. Actually it was z here, so let us take z here also. Okay, now let us see what will be the electric field due to this is plus, so this will have electric field like this. Okay, and this is minus, so this will have electric field like this, and there will be a resultant like this. Here your dipole moment is like this. They are in the opposite direction. This is the electric field. Here. So suppose this is theta, and this thing is also theta, and this is your theta. So suppose this is your E plus and this is your E minus, then what will be E? This will be E will be nothing but E plus cos theta, cos sin theta, and plus E minus, correct? Okay. actually here, this will have these components, this can be resolved like this and like this. Now, these two components in this direction, they are basically equal because equal charges are there. So they will cancel out. So only resultant will be like this. So this is your E will be nothing but your KQ upon this R square. Of course, this is your sine theta, and this sine theta and this sine theta, these two forces are, these fields are equal. So this will be basically 2 sine theta. Okay. So this will be nothing but KQ. Now 2 into what about sine theta? Sine theta is nothing but this divided by this. That means d by 2 divided by your R, and this is R square. So you can write it as R cube. Correct? So this will be your K, Q, 2, D, 2 to cancels out, sorry, Q into D, and this is your Z plus Z square plus D by 2 whole square 3 by 2. Now suppose you just take the Z out, 1 plus D by so again, since D is very much less than this Z, so we can cancel out this thing out, means this will be nothing but KP upon Z cube. So you see, if you are finding out the electric field on the perpendicular to this axis, then it is this, and along the axis this is this, means it is just double of this. And with this you can say that electric field basically varies in terms of 1 by Z square distance. That's why in case of isolated charges, you have seen it is KQ upon R square. It varies with the factor 1 by R square. Okay, suppose if you just double the distance, the electric field will be less by 1 by 4. But if you double the distance here, electric field will be less by 1 by 8. So in case of dipole, the electric field decreases very rapidly in comparison to isolated charges. There is one practical application of this dipole moment also. You must have seen the molecule of H2O. It is basically, there are 2 atoms and there is an angle of 105 between this H and O. This is 2 atoms of hydrogen and 1 atom of oxygen. So this is basically practical dipole. Because of this H, this side becomes positive and this side becomes negative. Correct? So there is a dipole like this which acts. You might have seen in the this has a practical application in the microwave ovens, because in microwave oven basically you heat the food, and how it is heated, because all your food items they have H2O, and what this microwave does, it produces a zigzag electric field. Due to this electric field, this dipole, this have energy, and due to this energy it gets heated up, and due to this your food also gets heated up. So this is a very practical application you can find, and you can study more about this. So this was basically all about the electric field due to the dipole at a distance z along the axis or perpendicular to the axis. Now we will see the line charges, how the electric field we can find out due to line charges. Now let us see, suppose you have this line conductor and you are asked to find out the electric field at point P due to this. Now it has a uniform charge. Uniform charge means, suppose this is the total charge here, it is Q, then naturally suppose it has got L length, then whereas Q is equal to lambda into L, lambda is nothing but it is the charge density per unit length. So suppose you are asked to find out what is the electric field at this point. So what you have to do, first you just draw a perpendicular, correct, and then you can like this. Suppose this is your theta 1 and this is your theta 2. And now since it is uniformly distributed, charge is uniformly distributed, so let us take, we have to integrate, basically let us take one segment here, that is at a distance L from here. This is your dl, and this is a subtending an angle of d theta, correct? Now due to this dl segment, let us see what will be the electric field here at this point. So you know, suppose this is positive, and then it will have the electric field like this. This will be theta, because this is your theta, correct? And this electric field will have two components. This is suppose Ex, and this is Ey, correct? So now we have to find out, if we know Ex and Ey, then we can find out the electric field at P, because this will be the resultant of Ex and Ey. Now here we have seen what is our formula. Electric field is nothing but K Q upon R square. Suppose this is your R0 and this is your the distance between this is your R. So naturally this is your R. What is Q? Q is nothing but here, because of this segment, what will it will become? It will be dE dQ upon R square, or this we can write it as dQ will be nothing but lambda dl. So here lambda dl upon R square. What is this R? R is nothing but R 0 upon R is nothing but your cos theta. So R0 is, R is nothing but R0 sec theta, correct? So here we can put K lambda dl upon R0 square sec square theta. Till now there is no problem. What is L? L is nothing but this L divided by this R0 is nothing but tan theta, or L is equal to R0 tan theta, or we can write it as dl is equal to R0 sec square theta into d theta. Till now there is no problem. Okay, so we can write it as K lambda dl is R0 sec square theta d theta upon R0 square sec square theta d theta. This reduces to lambda, this sec square goes off, then this lambda d theta upon R0, correct? So this is your K lambda d theta upon R0, this is your dE. Now what is dE? dEx is nothing but K lambda d theta upon R0. This is basically component of this. Ex is nothing but E cos and Ey K lambda d theta R0 sin theta. No problem. Dex. Now this we have to integrate, then we can find out Ex and Ey. So let us see. Ex will be this is your theta 1 2 minus theta 2 K lambda d theta cos theta upon R0, and this will be your This will be your K lambda d theta sin theta upon r0. Now let us see what is Ex and Ey after integrating. After integrating Ex and putting these values, your Ex will come as K lambda upon R0. This will be sin theta 1 plus, correct? And Ey K lambda R0 cos theta 2 minus. This you can do. You can simple. It is a very simple integration. Cos theta will be sin theta and just put the values. Sin minus theta 2 will be minus sin theta. So here it will become plus, and like that. This is a very simple calculation you can do. So this is basically the result you are getting because of this line charge. Due to this line charge at point P, you are having Ex and Ey like this. So let us see the other thing. Suppose you have a finite, in this case you have a finite length and you are asked to find out the electric field at P. You can easily find out because theta 1 you will be knowing, theta 2 will be knowing. You just put the values and your E will be nothing but Ex square plus Ey square, correct? There is no problem. Now suppose this is not finite, this is an infinite. In case of infinite length, infinite in case of infinite length, what will be your theta 1? Theta 1 will be nothing but your pi by 2, because the more it will go up, this angle will increase, and ultimately when it goes to infinite length, this will have the right angle. And likewise in this direction also it is having infinite length, and theta 2 will be pi by 2. Now you just put these values here. Pi by 2, this is pi by 2, it will become 1, 1, 2. This will be, in this case, Ex will be K 2 lambda upon R0. And what about this Ey? This pi by 2, this will be 0, this will also be 0, naturally. This Ey will be 0. And due to this, E will be nothing but Ex, and in case of infinite line charge, infinite length line charge, the electric field at any point at a perpendicular distance r0, it will be this, correct? Now suppose you have only half infinite length, means suppose in this direction it goes to infinite length, but here this terminates here and you are asked to find out the electric field at this point at the end of the wire. Then what will happen in this case? What will be your theta 1 will be pi by 2 because it is going up to the infinite length. There is no problem. But what about theta 2? This will be 0. Correct? So in this case, your Ex will be your 5 by 2, this is 0, that means this is K lambda upon R0. And what about Ey? Ey will be 5 by 2, it will become 0. Then this is 0 means 1, that means K lambda upon R0. Of course, this will be positive because theta 2 is 0 here. This is pi by 2, this will become 0. This will become 1, so Ey will be in this direction. So, and then you can take this. So, in case of this wire at a distance of R0, end of the wire at a distance of R0, this will be the value. This is an infinite. And I like that. So many permutation combination can be there, and you can find out the electric field due to a line charge. Now let us see what will be the electric field due to the ring. Now let us see the electric field due to, suppose this is a ring. And charge is uniformly distributed on this, and you are asked to find out, this is the radius is R of the ring, and this is the point P at a distance of X from the ring. In this case also you can do what you can do. You can take a segment. You can take a segment here, ds. Due to this segment, what will be the electric field here? This will be like this. Suppose this is a positive charge distributed on this. This Q will be nothing but lambda, total length of the 2 pi R, correct, and dq will be nothing but lambda into, correct. So this is the charge dq, and due to this is the electric field. It will have two components, Ex, Ey. This is theta, this is your theta. Here, this ds we have taken here, but when it comes here, then it will have a component like this. So due to this symmetry, this Ey component will be 0, and Ex will be your basically main component, and Ex is nothing but E cos theta. So here what will happen? Here basically your E is K Q upon R square. This is fundamental formula. dE will be nothing but K dQ upon R square. This is your R. Always from the charge to point, this distance is there. And this is nothing but K lambda ds upon R square, or K lambda ds upon R is nothing but your x square plus R square into, this is square, correct? Now, what is Ex basically? Your K lambda cos theta ds upon x square plus R square. Okay? Now this will become lambda cos theta. What is cos theta? Cos theta is nothing but this divided by this, means x divided by r. This r is nothing but this square plus this square, so this will become x square plus r square 3 by 2, correct? Of course, ds is there. Now, this is basically dEx. So, Ex will be nothing but K lambda x upon x square plus R square 3 by 2 into 0 to ds is what? 2 pi r. So this will be nothing but K lambda x 2 pi r divided by x square plus r square. This can be written as, because lambda into 2 pi r is nothing but your total charge. In terms of total charge also, this can be written correct. So this is basically the electric field due to this ring at point P. Now in this, just see, suppose x is 0, then this electric field is 0, means at the center. X is 0, electric field is also 0. This Ex is nothing but, because Ey component due to symmetry becomes 0. And suppose x, your x is 0 means this is 0 and x is very large, suppose. X is very large, then also this will become 0, because suppose if we take out this and x becomes to infinity, then again it will have a basically maximum value in between. So what we can do is, this expression we can differentiate. So this was the electric field we found out in our last expression due to the ring. Now we observe that at x is equal to 0, E is your 0, and when x is becoming infinity, then also it is becoming 0. Then where is the maximum values? Then what we can do is dEx upon dx. If we find out this and equate to 0, then we can find out the value of x. And suppose if you find out the value of x, it comes as r, this comes as by root 2. So x at this somewhere here, this is basically somewhere here where this distance is r by root 2, this electric field will be maximum. And what will be the value of this electric field? This will be E max. If you put the value, this will be nothing but K Q 3 root 3 R square. So this you can do yourself. Just take the derivative of this with respect to x, equate it to 0, you will find this value, put this value in this, and you will get this value. So this is the maximum value you can get here, and this is the kind of graph you generally get. This is the maximum value, max. I hope you understood this.